Right. 4 parallel plates are connected in a vacuum. An electron at rest in the hole of plate X is accelerated to the rate. The electron passes through the holes at W, Y with no acceleration at all, and then it passes through the hole Y and slows down as it heads to plate Z. We need to calculate the speed of electron at hole W. And part B, we need to calculate the distance in centimeters from plate Z, somewhere here probably, to the point at which the electron changes direction. So we need to find out the distance where the electron changes the direction. The distance here is 6 centimeter, 6 centimeter, and 6 centimeter. That's a very good example. So, what we have here, this one is going to be negative plate. This one is going to be positive plate because of this arrangement here. And on this side we have positive plate and negative plate. And there is no potential difference between W and Y. So that's why there is no acceleration in these two, between these two, because there is no force. Alright, so let's find out how much is going to be the velocity at point W. So in order to find that, we need to find out the acceleration first. We can say delta V equals to negative F times D divided by Q. Delta V is 400, negative F times D, which is 6 centimeter. If you write it in terms of meter, is going to be 0.06. And the charge for electron is negative 1.6 times 10 to the power of negative 19. Then we can find F. It's going to be 1.6 times 10 to the power of negative 19 multiplied by 400 divided by 0.06. So F will be 1.066 times 10 to the power of negative 15. Then we can say F equals to MA. A will be F over M. F is 1.066 times 10 to the power of negative 15. And M is the mass of electron, which is 9.11 times 10 to the power of negative 31. So that's going to be divided by 9.11 times 10 to the power of negative 31 is going to be 1.17 times 10 to the power of 15 meter per second square. Then based on this formula, Vf squared, which is the final velocity squared, equals to V naught squared plus 2 times A times D. Initially it's addressed, so initial velocity is 0. Vf squared equals to 2 times A, which is 1.17 times 10 to the power of 15, times D, which is the distance, 0.06. That's going to be 2 times 1.17 times 10 to the power of 15 times 0.06. That will be 1.404 times 10 to the power of 14. If you make it square root, Vf will be almost 1.18 times 1, 2, 3, 4, 5, 6, 7, 10 to the power of 7 meter per second. So that's going to be the velocity at hole W. Now in the second part, it says calculate the distance in centimeter from plate Z, which is here, plate Z is this one, to the point at which the electron changes direction. What does that mean? It means that Here, there's a potential difference here, nothing in here. So there is no acceleration, there is no force in here. So the velocity is increasing here. That's going to be the maximum velocity in here. Then it keeps moving with the same velocity as this guy until here. Then here, this one is positive plate, this one is negative plate. Since it has the velocity, it goes this way. Don't forget that we are dealing with negative charge. So it's going here, but since we have positive and negative, the electric field is going to be on negative charge, is going to be toward left. So we have force on the negative charge this way in this part. So we have acceleration toward left. So velocity is reducing until it becomes zero somewhere. And again, it gains some acceleration and velocity increasing, and it's going this way. So it never touches plate Z. So we need to find out where it becomes zero, when the velocity gonna be zero. So we can assume that velocity at point Y still the same velocity as W, which is 1.18 times 10 to the power of 7. We can also round it to 1.2 times 10 to the power of 7. Then we can say Vf squared equals to V naught squared plus 2AD. So this is going to be the initial velocity now in the third compartment. The final velocity is going to be 0. We need to find the D, but A is also missing. Let's find out A first. A is going to be the force. Since we actually found it in part A, but the compartment in part A and 3 is different. So we need to calculate it again. So delta V equals to negative FD over Q. Therefore, it's going to be 7,000 equals to negative F times 0.06 divided by Q, which is negative 1.6 times 10 to the power of negative 19. F will be F will be 1.867 times 10 to the power of negative 14 Newton. So A, which is acceleration, is going to be F divided by M, 1.867 times 10 to the power of negative 14, divided by (9.11) mass of electron, 10 to the power of negative 31. So that's going to be divided by 9.11 times 10 to the power of negative 31. That's going to be 2.049 times 10 to the power of 16. Let's say approximate 2.05 times 10 to the power of 16 meters per second square. Now we sub it there. The final velocity is 0. Initial velocity was this one, 1.2 times 10 to the power of 7 to the power of 2 plus 2 times, since it's decelerating, it's going to be negative, so negative 2.05 times 10 to the power of 16 times D. So that's going to be D equals to 1.2 times 10 to the power of 7 to the power of 2 divided by 2 times 2.05 times 10 to the power of 16. So that will be 1.2 times 10 to the power of 7 to the power of 2. That will be 1.44 times 10 to the power of 14 divided by 2 times 2.05, 4.1 times 10 to the power of 16. That's going to be 3.51 times 10 to the power of negative 3 meters. If you want to have it in terms of centimeters, it's going to be 0.35 centimeter from hole Y. So since it's from hole Y, it's going to be somewhere very close to hole Y because it's nothing. It's 0.35. The question asks, calculate the distance in centimeters from plate Z. So it needs to find out this distance. So the whole thing is 6 centimeter. So it's going to be 6 minus 0.35. That's going to be 5.65 centimeter to the left of plate Z.